Welcome once again, children of grade 5. We're here again to explore more about mathematics, in particular sets. But before we get into today's lesson, we are going to look at the homework from the previous lesson. So let's get started. The activity that you had to complete for homework says write equal or equivalent for the following pairs of sets. Write equal or equivalent for the following pairs of sets. Number 1, we have the first set with 1 as its member and another set with A as its member. So, the pair of set, children, is it equal or equivalent? Now, because the two sets have different members, we are sure that they are not equal. However, they both have one member, so they are equivalent. Number 1, equivalent. Number 2, the first set has the members 6, 8, 9. And the next set says composite numbers less than 9. Composite numbers less than 9. So what are the composite numbers less than 9? Let's see. Composite numbers have more than 2 factors. So the numbers with more than 2 factors that are less than 9 are 4, 6, 8. 4, 6, and 8. Now, 3 members. So would number 2 be equal or equivalent? If you said equivalent, you are correct. Number 3. The first set has members 1, 4, 9, 16. 1, 4, 9, 16. Its pair has members square numbers less than 25. Square numbers less than 25. So we have to figure out what are the square numbers less than 25. So the square numbers, which means when we multiply a number by itself, that is a square number. The result is a square number. So let's see. 1 times 1 will give us 1. 2 times 2, 4. 3 times 3, 9, and 4 times 4, 16. 5 times 5, 25. But they said less than 25. So the square numbers less than 25 are 1, 4, 9, 16. So it means that the pair of sets are equal. Number 4, the first set has members 0, 1, 2, 3. And its pair has members that are whole numbers from 0 to 3. Whole numbers from 0 to 3. Now the whole numbers from 0 to 3 are 0, 1, 2, 3. So it means, children, that that pair of sets, They are also equal. Equal. Let's look at number 5. The first set for number 5 has members 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And its pair has members that are natural numbers less than 6. Natural numbers less than 6. Now we know that natural numbers are the whole numbers from 1. 0 is not a natural number. So the natural numbers less than 6 are 1, 2, 3, 4, 5. So it means again we have equal sets. Equal sets. And the last of the homework, number 6, the first set has members X, Y, Z. X, Y, Z. And its pair has members that are consonants between A and E. Consonants between A and E. So let's list the consonants between A and E. The consonants are B, C, D. B, C, D. So we can definitely see that those two sets are not equal, but they are equivalent since they have the same number of members. So that's it for our homework. Today, we are going to continue to look at sets. However, we are looking at the union and intersection of sets. So today, we will be able to define the terms union and intersection, and we will also be able to find the union and intersection of given sets. Are you ready to get into the lesson? I sure am. Let's dive right into it. First, we are going to look at the union of sets. So when you hear the word union, what do you think of? Sure that you would have come up with answers like unite, join, bring together. All of those words are correct. The union of two sets is all the elements of each of the two sets combined. The union of two sets is all the elements of each of the two sets combined, which means we bring together or we join all the members of the two sets. When we find the union of sets, number 1, we unite or join the members of the different sets. We do not list a member more than once. We list the members in curly brackets and separate each with a comma. When we find the union of sets, children, we unite or join the members of the different sets. We do not list a member more than once. We list the members in curly brackets and separate each with commas. The symbol for union is, let's look at an example. Here we have two sets. Set A equals 1, 2, 3, 4. Set B equals 2, 4, 6. Can you see that? Now, if we're asked to find the union of set A and set B, this is how we write it. A, the symbol for union, B. So A union B equals, and remember, we're listing those members in curly brackets, and we're going to separate each with a comma. A union B equals, let's join those two sets together. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Children, we must ensure that we include all the members of the two sets. However, we do not list a member twice. So if you notice, in set A, you have the members 2 and 4. Those members are also found in set B. When we are finding the union of the two sets, we do not list the members 2 and 4 twice. Let's look at another example. Here we have what we call a Venn diagram. Remember in a previous lesson, we said that we can represent sets in loops or in shapes. Now here in the Venn diagram, we have set A and we have set B. A union B would be all the members of the two sets. In set A, the members are, do you know which members are in set A? Correct. If you said 2, 5, 7, that is indeed correct. 2, 5, and 7 are members of set A. Now, what are the members of set B? That's correct also. 1, 2, 5, and 8 are the members of set B. 1, 2, 5, and 8 are the members of set B. Now, I am sure that you have noticed that the members 2 and 5 belong to both sets. 2 and 5 belong to both sets. Now, when we're finding the union of set A and B, we're going to bring those two sets together. So we're joining their members. So the members of A union B are 1, 2, 5, 7, 8. Now, I'm sure you would have picked up that no member was repeated. 1, 2, 5, 7, 8 are the members of A union B. So once again, children, what do you understand by the term union? Union means to join together or unite the members of two or more sets. Excellent job. So now that we understand what the union of sets is about, we're going to look at the intersection of two sets. Intersection of two sets. So what the term intersection means? Sometimes when you're traveling on the road, your parents would say, we are at an intersection. What do you understand by that? Think about that a little. Okay, if you said an intersection is where two roads meet or cross, you are absolutely correct. So today we're going to look at intersection of sets. So the intersection of two sets is all the elements that are common to both sets. Again, the intersection of two sets are all the members or elements that are common to both sets. So when we say common, what do we mean? The members that are the same. The members that can be found in both sets. The symbol for intersection, children, is this. The symbol for intersection. So let's look at an example. We have set A equals 1, 2, 3, 4, and set B equals 2, 4, 6. Now we are going to look at A intersect B. A intersect B. So if we're looking at A intersect B, it means that we have to look at all those members that are common to set A and set B, or the members that are the same in both set A and B. Have you recognized those members as yet? Now, A intersect B equals 2, 4. So 2 and 4 are the members that are the same in set A as well as in set B. Great job, boys and girls. So far, you know what the term union means, and now you know what the term intersection means. Let's look at intersection using a Venn diagram. So example 2, we have this Venn diagram. Now, which part of the two sets, A and B, is shaded? Which part or section of the two sets, A and B, is shaded? Of course, we can see that the middle section, or the part where the two sets join or where they meet, That part is called the intersection. Remember earlier we said when two roads cross, we have an intersection. Well, set A and set B, they're overlapping in the middle. So that is the intersection of the two sets. The members that are found in the middle belong to both sets. That's what intersection means. So now you have a full understanding of what the term intersection means. We have to also learn two other terms. Now, when we talk about intersection of sets, you must understand the terms joint sets and disjoint sets. Joint sets and disjoint sets. Now, joint sets have common members. That is, they intersect. Disjoint sets do not have common members. That is, they do not intersect. Here is an example of disjoint sets. Are they intersecting, children? No, because they have no common members. So let's recap. The union of two or more sets would be those members that we join together. When we join the members of two or more sets together, we would have found the union of those sets. Remember also, we do not list members more than once. The symbol for union is the intersection of two sets would be all the members that are common in both sets. So the members that are the same belong to the intersection. And if we are to represent those sets using a Venn diagram, we have to draw those sets joining or intersecting. The common members would be in the center of the two sets. The symbol for intersection is So, boys and girls, today we would have learned about union and intersection of sets. Like always, you have homework to complete. Your homework for today says, list the union and intersection of the following sets. List the union and intersection of the following sets. Now an example is done for you. Example, we have set X equals the first three multiples of 6. Set Y equals factors of 24. Now, before we can find the union or the intersection of sets, we must list the members of these sets. So the members of set X are 6, 12, 18. The members of set Y are 1, 2, 3, 4, 6, 8, 12, 24. So, X union Y, which means we are joining those two sets together, or we're joining the members of those two sets together, is 1, 2, 3, 4, 6, 8, 12, 18, 24. And x intersect y, which means we're looking for the common members of set X and set Y. These members are 6 and 12. 6 and 12. So now that you have an example done for you children, please ensure you complete the homework, and when we begin the next lesson on sets, we are going to explore the answers. Thank you very much. See you until next time.